Hi Maya, I'm going to try to record the solution of this problem. Hope it helps you for the group assignment and also for the test. So we have three statements of polynomial. So then we go ahead and find the roots of each of them. So x squared equals 1, you have a root for 0. X minus 2 equals 2, you have another root here 2. And you have another root here for -5. Okay, so then you put those roots in order. We're talking about the sign chart method. So you'll start with -5, then 2, 0, and 2. So this line should be in an increasing order, same as like number line order. And then you place their roots where they belong to, like this, Christmas trees. And 2 is a root for x minus 2. Right, and then you complete the boxes. Alright. Then you go to that each place where -5 is a root of x plus 5, and you decide the sign on the both sides of the box. So if I give values between -5, higher than -5 for this statement, will be positive. Because this is positive, that will be negative. Since there's no more roots, that will continue as positive. For x, it will be positive here, it will be negative there. However, we have x squared. So doesn't matter, although 0 is a root, it will be positive everywhere. For x minus 2, it will be positive for the values greater than 2. Values less than 2 will be negative, and continue with that. And now you're going to multiply them. So you get plus here from this column. From this column you get negative. From this column you get negative, and you get plus. So what were we looking for? We were looking for greater than equal to 0. So then this interval and that interval will be our solution. How are we going to write that down? Remember, this interval will be -infinity to -5, and this interval goes with 2 to positive infinity. So then our solution here will be -infinity to -5. That will be a bracket, because we have that little line here, we need to include it. Union, we're going to go to positive infinity. So this is a sign chart one. So if we go ahead and do this problem by using the polynomial graphing, right? Let's see. This is my y-axis, this is my x-axis. I will put the roots again here, right? -5, 0, and 2. Alright, so I do have a second, third, and fourth degree polynomial with positive leading coefficient. Okay? And then the end behavior will be like x squared, which means like that, because the even degree and positive. So then my graph should be finishing something like this. Now I'm going to look at the multiplicity at x squared, which is 0. I need to be touching. X minus 2, which is 2, I need to be cut through. X minus 5, I need to be cut through. And because we have like that. Okay, so that will be our graph. On that graph, what do we want? We want the graph to be greater than equal to 0. So this is the solution then. This portion and this portion is this solution, because we're looking for the function values which is greater than 0, which is above the x-axis. And are we going to include -5, 0, and 2, yes. However, not 0, because 0 is not in solution intervals. So don't worry about the 0 there. Just a second. So let me click. Yeah, so the purple line. So the graphically and algebraically through sign chart, we have obtained the same solution. So this is about the problem, I think 2. And you have another problem about the walkaway. So with this walkaway problem, we were looking for, I'm going to pull out the problem. All right, so write a function representing the overall area of the pool and walkaway in terms of variable x. The overall area. So inside we have x and x minus 5. So I need to figure out the area of all. So then in area of all, I will have x plus 2 and plus 2. So I'm interested in this portion first of all. And that will be x plus 4. Right? Because I have, oh no, not x plus 4 here. No, x minus 5 plus 2 and plus 2, that will be x minus 1. Because this portion is already x minus 5. This is that portion. And we are adding 2 feet top, 2 feet at the bottom. So that will be that length. So now we need to look at what's happening at the bottom. So we do have x. And we are going, let me see, 2 feet here and 2 feet there. So this length will be x plus 4, right? So x minus 1 and x plus 4 will be length and width of the area of a rectangle. Times x plus 4. So area in terms of x, that's how we write it down. Hope this helps. All right. See you soon. Bye.